Okay, so we're going to do this by elimination, and we notice that we do not have everything lined up. X's are lined up fine, but the Y on the top equation is on the right of the equal sign. On the bottom, it's on the left. So I'm going to start with that. I'm going to move the negative 3y to the other side by adding 3y. So I get 4x plus 3y equals 8. Now I'm looking at these two equations, the last two, and I want to see if there's the same number in front of the x or the same number in front of the y's. And I don't have that. I have negative 5 and 4 in front of the x and 4 and 3 in front of the y. So to create the same number, I'm going to use multiplication. And that's a valid thing to do as long as I multiply every term by the same number. So I'm going to try to eliminate my x's because they have different signs right now. I could remove my y's by creating a 12 and negative 12 in front of the y, and that would be totally valid and great. But I'm going to work with the x's. The least common multiple of 5 and 4 is 20. So I'm going to try to create a 20 in front. They have opposite signs already, so that's awesome. And I multiply the top one by 4 to get a negative 20, the bottom one by 5 to get a positive 20. And the second equation, and when I add, what's so awesome about this is when I add these together, the 20x's drop off because they're opposite in sign, and it makes a 0. Here I get 31y equals 124. If I divide both sides by 31, I get y is equal to 4. Now to find the x value, I can go up into either equation from the beginning that has both variables, actually any equation, and I get 4x is equal to negative 3 times my y value of 4 plus 8. I'm just combining like terms because x is on the left. And then I'm going to write my ordered pair, x first, then y. I can always plug it in the originals. 4 times negative 1 is negative 4. Negative 3 times 4 is negative 12, plus 8 is negative 4. Negative 5 times negative 1 is 5. Plus 4 times 4, which is 16. 5 plus 16 is 21. So I know I have it. Did it. Awesome.